Thank you, Jess, and hello, everybody. Welcome to the webinar. My name is Samir Jaber, and I will be your host for today. And with me are two experts in the tech space that I'm really excited to have this conversation with. They represent Renesas. Now, I'm sure a lot of you are already familiar with Renesas and what they do, but for those of you who are not, Renesas is a tech giant. They are a leading semiconductor manufacturer out of Tokyo, Japan. They've been around for over 2 decades, and their mission is to create a world that is smarter, safer, healthier, and greener. So we're really excited to host them here today in this discussion. So today's webinar is about powering edge and endpoint applications, and we want to have an in-depth discussion on a specific technology called Reality AI Tools from Renesas. So with me today are Mr. Mo Dogar and Mr. Jeff Siraki. So Mo is the head of global business development and technology at Renesas Electronics, and he's responsible for the promotion and business expansion of the complete microcontroller portfolio and other key products as well. And he is at the center of driving global business growth and aligning marketing, sales, and development strategies, particularly in areas like IoT, AI, security, and of course, smart embedded electronics. So Mo, it's a pleasure to have you here. Thank you for joining.
It's a pleasure. Thanks, Samir.
We also have Dr. Jeff Siraki. So Jeff is an expert applied mathematician who has focused his career on the intersection of modern signal processing and machine learning. Jeff is the former co-founder and CTO of Reality AI, and he joined Renesas as part of an acquisition back in 2022, and is now head of AI engineering at the Renesas AIoT Center of Excellence. Jeff's work spans from signal and sensing applications in the commercial industry to medical devices and DoD applications. So Jeff, it's a pleasure to have you as well. Thank you for being here.
Great to join you today. Thanks.
All right. Before we jump into the conversation, as Jess mentioned, if you haven't seen already, we have launched only recently a technology report, together with Renesas and other leading technology companies on Edge AI and its applications in various industries, including manufacturing, healthcare, automotive, smart cities, retail, etc. So go check it out through the link that Jess mentioned. I happen to have a copy of it here. It looks like this. It's the 2024 State of Edge AI report. So go check it out. It's free to download. So let's get started. As I mentioned earlier, we all know that Renesas is a leader in microcontrollers and machine learning, but Renesas offers a lot more. So Mo, if I can start with you, can you provide our listeners with an overview of Renesas as a full system provider, and how does this approach set Renesas apart in the industry?
Great. First of all, hello everyone who's joining the webinar. It's a pleasure to be here, Samir, with you and the people around the globe that are joining this. Yeah, I mean, as you mentioned, Renesas is a global semiconductor leader. In terms of providing electronics, intelligence devices across a whole host of applications. It ranges from microcontroller to microprocessors. We have a very large portfolio of connectivity devices, as well as a complete suite of analog and power products, ultimately providing a complete solution to any IoT, automotive, or industrial applications. We've been around for several decades, right? So, a global company. Really, our mission is to, enable the smart society globally. Particularly in the field of AI, we feel that it's an excellent timing right now. If you think about the key technologies like IoT, 3G, and I kind of maturing at the same time, and also the whole idea of where the distributed intelligence is coming into play, where we want these edge devices which are low resources, resource constrained devices. We want to enable them, with AI, and ultimately, services and solutions that can add value to customers. And our value really comes, if you think about it, from those edge devices. We're saying to customers, you can add those intelligence without changing your hardware because we can provide really optimized solutions. And, we can talk a little bit more on that later on. But not just that, we're looking at a whole spectrum of AI. AI is going across all the aspects of our lives and applications. So ranging from vision AI in the factory space, in the security space, and people detection, etc., to voice, this is linguistics, natural language understandings. We want to speak to the machines these days to be able to control them. And finally, what we call is real-time analytics or time series. So really covering the broad range of AI, again, backed by our solutions in terms of product, but also in terms of our core technology as well. So, ultimately, with Renesas, what you get is a solution provider that can help you add value and add additional service, and ultimately, reduce your time to revenue.
That's really really interesting, and I mean, AI today it's the hottest topic in so many spheres, right? It's the technology that both experts and non-experts talk about. So, Jeff, if I may loop you in here, what are your thoughts and opinion on the current AI market and technology landscape in general?
Oh, sure, sure. So as you say, AI is evolving faster than ever. It's in the news daily. It's top of everyone's mind, right? Things like autonomous driving, generative AI, that's really, hitting the headlines kind of on a regular basis. But at the same time, it's bifurcating into topical areas somewhat, right? So you talk about generative AI, that's the big dog right now. It's still being run on massive server farms to make it happen, right? But then we go to large language models. Those are still pretty big models. They're very impressive. You can talk with your computer, and they're trying to put those in smaller places. As Mo mentioned, we've got vision, right? These are still big deep learning models. But they tend to have more specific applications these days, right? As you said, people recognition, object counting, that sort of thing. We move down to voice, right? These are really much more canned applications now, right? People don't want to design their own. They want a wake word detector, and they want to, determine whose voice is speaking, and then connect that to their large language model, right? And so, in moving down to real-time analytics, which is where we really, focus. There, we're putting detection about a detection of the quality of signals into very small MCUs, and everything becomes far more specialized and bespoke. So this landscape is very broad, and yet it's not all quite the same thing, even though it's under the same umbrella. We see a lot of effort to put big models in small places these days. To some extent, MCUs are evolving to keep up, right? Renesas has the new RA8 line, based on the Cortex M85, which can run some substantial vision models. But at the same time, AI is moving down market to try and go into small spaces, little MCUs, right? So customers can put this into every consumer device and IoT device because it saves them development time. In terms of direction, and I think Mo may want to add to this as well, I think we're seeing a shift toward more AI solutions rather than just more AI build capability in itself, right? Because really, customers eventually want technology they can adopt and adapt to their own specific use cases rather than always having to build it from scratch.
Yeah. Great. I think I see kind of moving forward. There's a lot of noise, right? Look, there's AI is everywhere. What ultimately, what customers are looking for, is how do we add value to our application without adding a lot more dollars to their bill of material? And the second challenge we see is that, if you think about the AI and the embedded world, they kind of lives in two separate domains today. So most of us are not data scientists. How can we enable those embedded engineers who are, or maybe mathematicians, who are embedded developers to actually develop optimized model to solve a certain problem or anomaly detection? And if you think about from the AI space, a lot of the tools that are out there are a separate workspace. So you're developing, you're having some way to, collect the data, optimize, look for certain anomalies that you want to do, develop a model, and then you got this completely separate embedded domain. How do we bring these two worlds together? It's important. If you want to accelerate, if you want to enable the mass, one of the vision from Renesas is to enable AI for the masses. It can only happen when we can enable those engineers to develop seamlessly, number one. And number two, Jeff talked about large language models, and think about the sustainability aspects, right? It's actually unsustainable today if amount of resources are required to run some of those large language models. So I think one of the areas that we're seeing, where Renesas is also developing a lot, is to actually extend the capability of those devices by having more sophisticated hardware acceleration tools that can actually accelerate, in terms of the whole AI model performance. And I think the secondly, work within a smaller set of models, right? This challenge of having too much data these days, right? How do we turn that data into revenue? So I think there's going to be a lot of development and optimizing and having more sustainable, low power solutions while managing the edge AI in terms of real-time analytics all the way to Gen AI running on the edge. And I think finally, you want especially with the distributed computing, where you don't have a cloud backup, you want those devices to make real-time decisions, right, in the field. So I think that one of the capability is that you want those devices and those models that's running on those devices to learn on the go, right? Because as the sensor inputs are changing in a factory floor, how do we adapt to that? So I think that kind of intelligence is also important as well. So I think it's an exciting journey, a lot of development on the hardware side, but also making the tools and the development journey easy for developers to take the next step.
That makes a lot of sense. I mean, and just to reiterate what Jeff mentioned, like the diversification or sort of the diverse application of the technology today, all put under one umbrella, sometimes sort of it maybe allows people to miss how really diverse and how really sort of bifurcated this technology has become. And but speaking of solutions, speaking of real-time decision making as well as one of the most important aspects here, I want to take a deeper look into the solution we want to focus on today, which is Reality AI Tools. Now, some of our listeners are probably already familiar with this solution, but for those hearing about it for the first time, um, uh, Jeff, could you maybe describe what Reality AI Tools is? Why has it been developed? Who does it primarily serve, and how does it serve them?
Sure, happy to. So Reality AI Tools is a suite of cloud-based tools that fundamentally enables data-driven engineering of tiny C-code inference modules that will make live decisions on the edge, right? So we turn example signal data into decision code that can be deployed on embedded MCUs in a fairly automated fashion. It was purpose built with basically three things in mind. One, we targeted MCUs from the start. We wanted to make sure things were tiny, right? And that really was an obligation. MCUs are getting more powerful, but they're still pretty small when you're talking about some of these down market chips, right? Secondly, as Mo alluded to before, we were working with engineers that are experts in their own domains, but those domains are probably not machine learning, right? We don't want people that have to become experts in Python coding to get the job done. And finally, we narrowed down to real-time analytics, or basically signals as a focus, right? That was the three things we had in mind when we built it. Now, there are other tools, that have come along that the area has been tended to be referred to as auto ML. But in fact, it started out really as more of, in our minds, auto feature discovery rather than auto ML. By which I mean, we realized that in order to hit this MCU target, tight decision code hinges on finding the best means of telling group A from group B, right? So finding a good feature space enables us to select a really simple decision module that can solve the problem. So we don't always need to jump into deep learning and struggle with huge models. So that was the basis of the tool. And from there, we added quality management features to manage your data, the ability to test and refine your models online, to enable optimization of BOM costs, right? So sensor quality, sample rates, noise immunity, right before you commit to hardware. And finally added the ability to explain the decisions being made by the model so the engineers can validate what's going on. In the last year or so since joining Renesas, we've added linkage, round-trip linkage to the E-Squared Studio, right, which is Renesas's in-house IDE for working with our cores. So the users can actually collect the data directly from their device. They can build and optimize the modules and deploy them right back into their embedded devices. And not just our evaluation boards, but their own custom hardware that employs Renesas MCUs. So that's a big picture, nutshell, so to speak, of Reality AI Tools.
Yeah, I mean that's really impressive. I mean, but speaking on the application side of the technology, are there any specific industries or any specific application areas where reality AI tools excel more than others?
Sure, we focus, as I said, on real-time
Yeah,
analytics,
I mean, let me actually,
single. Yeah, okay, yeah, go ahead, Mo.
sorry, Jeff. Yeah. No, I was gonna add, I think a very important point that you made earlier. Just want to elaborate on a little bit on the explainability, right? Look, if you think about the AI today, certainly in a real-time industrial application, you don't want this to be a black box. I think as
Right.
Jeff explained, our technology from Reality AI is explainable AI, which means it's deterministic. If I am running an AI anomaly detection on a factory floor, in a robot or whatever, right? I want to make sure I can have a real time determination of what's going on. So I think that's a really important point. Sorry, Jeff, I just wanted to underscore that a little bit. I think this is what sets us apart. That it's not a black box for our customers. They can really see exactly at different stages of their model development and deployment that is fully explainable and deterministic.
Yeah, thanks for that, Mo. And I think that's really crucial, at least for people who, even for people who are not completely like experts or familiar with the technology, who just need the technology to work for their application. This is a perfect, an ideal solution, I would say, for them. But Jeff, back to you. So we were just talking about application areas for the technology where it excels. So could you maybe mention a couple of areas where you think this is the target market for the technology?
Sure, sure. As I mentioned before, we focus reality AI tools on signals, right? We've generalized to call that real-time analytics. So what do I mean by a signal? Anything that, as an engineer, you can draw as a squiggly line, right? Sound, vibration, pressure, electrical, ultrasound, radar, et cetera, right? So this leads us naturally to be quite good in areas of machine health, with, for example, system monitoring of HVAC, compressors, appliances. We're in automotive, pump anomalies. We had a lot of success with arc fault detection, right, in the
Right.
electrical side. And in fact, we've had a lot of work in motor control recently, particularly what we call sensorless, where in fact we're able to capitalize on the virtual signals generated by the motor control algorithm and don't even need to add an extra sensor to figure out what's going on, when the motor's out of balance and so forth. So those are some examples there. And we've also had some successes in audio, acoustics, like our Sing with Sound program.
Mhm.
Mo, does anything else come to mind in terms of things we're hitting the nail on the head with?
Yeah. I'm thinking of, I mean, yeah, we work, as Jeff said, we work across different industry and the application are just endless. One of the application that's coming to my mind is battery power systems, right? We have a lot of applications with batteries these days. We actually solved a real problem for a major leader in a power tools area recently, where they want to predict the temperature difference of different components in the battery system, right? Using the least amount of sensors. Imagine, when the battery is, battery, especially in an overheating situation, battery can discharge very quickly. And so this is basically the thermal model is critical as it helps protect that. So what we did is we looked at the customer use case and actually developed a prediction model, right, where we can actually predict the value almost, down to over 95% accuracy with a very minimum set of sensors. And the interesting thing for it was we were able to run this on a 16-bit our RL78 microcontrollers with a very small footprint, in terms of about, I think it's about 140 odd bytes of RAM and about 5K of flash and, a very, very small CPU overhead. So, the application is really endless. And as, uh, as Jeff said, right, it's really making sure that those applications can function with their application plus any other prediction they want to do. And we have a whole host of application in the pumps, for industrial pumps, in the appliance area. Interestingly, recently we solved a problem for our customers. We had it was an unbalanced condition. Imagine a washer running in your utility at 22,000 RPM or a dishwasher, right? You want to make sure that it's stable. It's a safety concern, right? In a lot of these manufacturers using accelerometers, to detect unbalanced conditions could cost around $3 to $4. We were able to remove that sensor, right, and achieve more than 95% accuracy using different current and voltage signals, and ultimately provide a solution based on our a 6T1 product where, not they just added a anomaly detection, but also saved the bill of material. The list goes on, in terms of the applications that we can address. But yeah, really,
Wow.
really helpful across many
Yeah.
applications.
That's really impressive. Yeah. I mean, and it's a good leeway actually to my next question because I mean, we've talked about the technology, we've defined what the technology is, we've talked about the application areas and then some use cases. But I want to understand what sort of separates this technology from the rest. So what is the unique value proposition of Reality AI tools compared to other solutions in the market? So how does Renesas differentiate itself in this space? So the question is to both of you. So Jeff, if you'd like to start.
Sure. I think Mo really alluded to exactly what we're after, running tight, small modules in very small places. And we pulled off some impressive AI even on these tiny integer chips. We think small by design, right? Other AI tool makers, really, they started out the other way around, right? The world was very excited about deep learning and every problem was being attacked with that particular hammer. Then after the fact, they started to trying to squeeze these big oversized neural network models that their packages produce into small places. And it's not trivial to do that. It's possible. There's a lot of great mathematical work on it, but it's hard. Instead, we built bottom up, targeting the MCU. So that's really, I think, the major differentiator right there. And even now, we are regularly able to solve real-time analytics problems with less flash, less RAM, less CPU resources. And in addition, tying back, because the models are simpler and aren't, layer after layer after layer of complex neural network, the models are explainable. We can figure out how the decisions are being made, right? So that's the second and important piece. But let's be clear, right? Renesas sells silicon, right? So our AI helps make use of that silicon, makes it, helps the user get to a product. Our AI tools, right? Reality AI tools does some things very well. But we also have an ecosystem of partners that do other things very well, all generating AI in our cores. So I think we're very proud of the niche we hit. But there's other parties that we're playing with as well.
Yeah, yeah. No,
Yeah.
that's really cool.
If I can just,
Mo, I was just
sorry, yeah, I mean, just to add.
Go ahead, Mo.
Yeah, no, it's fine. I think maybe there's a lag in my audio today. But yeah, I think one of the things which I highlighted at the beginning, I think is also important. How do we automate most of the process? So in the Reality AI tools, the automated selection of the feature spaces, if you compare this to other competitors in the market in a similar space, we can do this, in automatic fashion. Also, the feature parameters and feature tuning, right? So it's easy to, ultimately, once what data you need to collect, we provide the support on that as well in terms of some consultation. Then you want the tool to do the magic and actually develop that actually generate the machine learning model automatically. And that's, I think, it really saves a lot of time as well. And we do cover all sorts of models, right? Whether it's classification, regression, anomaly detection, as Jeff also mentioned, if you're going beyond, maybe if you have, customers have their own model, right? They bring their own model, then we have our EAI translator tool that can help translate the model into the embedded space as well.
Mhm.
Ultimately, I think, look, we are here to solve real world problems for customers, right? It's not a luxury, right? It's about solving a problem, and making the journey easy for the customers. And that's where I think we really excel.
That makes a lot of sense, and that's really, really impressive. Now, before I jump into the following questions, I just want to speak to the audience. If you have any questions, just to remind you, please make sure to put your questions in our Q&A chat, and we'll make sure to respond to them and get to them in the Q&A session at the end. So we'll have, I think, 10 to 15 minutes of Q&A. So please do add your questions to our panelists, and we'll get to them by then. But let's look at this in a bit of a different way. So I mean, we've talked about the different examples, different benefits and advantages, but I want to look at this from an example point of view. Let's create a hypothetical scenario here, right? So let's say I'm an interested prospect and I want to build a couple of dedicated edge AI models for my product. It could be an edge product or standalone product, and I'm very keen to minimize my additional engineering investment. I don't want to add too many headaches to my team. I don't want to add too many additional costs, right? So what are the key benefits I can expect to gain from implementing Reality AI tools in developing my system, and how would you say this would resolve my bottlenecks here? So Jeff, may I start with you?
Sure. So I want to be clear that Reality AI Tools is a very, very powerful suite, but it's not just software. It's a philosophy of working with customers to get good results, right? So when a customer gets serious about solving a problem, we don't just generally toss them the keys and say, go have fun, right?
Mhm.
Our customer success team will work with their engineers for a bit to understand the problem, right? The goals, their available data, and maybe help them organize a data plan if necessary, because machine learning and AI is critically dependent on data. If you mess that up, nothing's going to work out right and no one will be satisfied and lots of recriminations later. So you got to get that right. We may also work with them on their instrumentation plan a little bit, just to make sure they've got an idea of how they're going to deploy this eventually. It doesn't have to be perfect, but consistency in data flow, data channels is very important for these small bespoke MCU models. Okay, so that's sort of preliminaries. Those out of the way, right? We'll work with the users. They'll load up a representative test set of data. We'll run what we call our AI Explorer and work through a proof of concept, basically, right? Determining the feature spaces that work well for making discriminations, and our system will propose some architectures for the model. Okay. Now, often at that point, we are getting very good results right there. It's a great start. Either way, the next step is to move from that POC to generalization, where we'll test against larger and larger data sets, maybe add to the training set to make sure we capture real world variation, right? It's an iterative process. The customer is usually taking over right about there, right? They understand how things work, they understand the flow. If they haven't done that already, now they're in the groove, so to speak. And the customer or us working with them, we can then take the models they're generating, optimize them, right? We'll run what we call these bill of materials optimization tests to see which channels of the data are most important for making decisions, see if we can drop any of them, right? Which sample rates are necessary? Can we reduce that sample rate? That saves cost. Check against noise immunity, maybe tweak the error balance. These are all tools and features within Reality AI tools. So that the end user can optimize their models and make sure it solves the problem they need to solve and make trade-offs according to their own criteria, whatever they may be. So,
Yeah, please go ahead.
Yeah, sure. So then we can look at the model for explanations, right? We can show that to the users. And this is another important stage of use of the development process, right? The engineers can kind of do a sanity check, right? If they're looking at vibration in pumps and, we're telling them that they can explain cavitation, maybe with some kind of Fourier-based frequency space, does that make sense to them? They go, yeah, okay, it found something reasonable. Might not be the first thing I went to, but it makes sense, so I believe it. And that's very helpful in this age of AI. And then at that point, or any point really, we can deploy a model into an embedded library to test it live. So again, either on the development boards or on the customer's own hardware. And we'll test, and we may iterate again if we're not seeing the live results we want, right? And so we will continue this way until the users like what they see, at which point they have an embedded library ready to go into their code and deploy.
That really makes a lot of sense. I mean, if I may ask, how long, what kind of timeline do I like for everything that you just mentioned in terms of training the models and trying to create that library? What time span can I expect for this?
You probably expect my answer, right? It depends.
Yeah, yeah.
Of course, to get something all the way to market can be a while because you want to make sure it works. You don't want to release something that's halfway there and not validated. But the initial results can be extremely quick. We often schedule the getting started POC to span about 2 weeks at time. So once you've got data, it's a very fast feedback process, and they can see early on how well they're doing and apply any gateways they need to do to refactor the project.
Oh, that's really impressive. Mo, do you have anything to add on that?
Yeah, I think I just from a customer point of view, I think the beauty here is that, look, AI is specific, right? It's not general to what you're trying to do. And as Jeff said, your model and your outcome is going to be as good as the data. And we were doing some analysis. Creating the model itself is the smallest piece of the work, actually. it's about all the things you have to do beforehand, in terms of what kind of data you really need to collect, classification of that data, the instrumentation part, which is extremely important. Now, think about a placement of a sensor few millimeter right to the left of a certain machine. It's going to make a huge difference. So this is where really the value comes from, how Jeff was explaining, that if you can assist the customers at the front end, I think the outcome's going to be better, right? So I think that's really what I wanted to add here as well, that I think, it's all about planning and having that prototype and being able to deliver a successful prototype that you can go into production with.
Let me underscore again that when I talk about a bespoke model, right? What do I mean by that, right? So we're trying to put these models on very small MCUs. So that means we do not have the resources to generalize massively, right? We don't have a server farm. We're not, in some cases, talking to the web at all, right? So if we could have a large model, we'd have a lot more leeway to build something that's very big and very general and solves any problem in any variation. But in order to fit it in a small place, we've got to be specific, right? It's going to learn how to work with this particular kind of machine with this particular sensor. And that's what we mean by bespoke and data being rather critical at that stage.
Of course, of course. No, that makes a lot of sense. Now, I want to take a step back, and again, if anybody has any questions about Reality AI tools, please do ask them in the Q&A chat. But I want to take a step back a bit and look a bit further, look beyond Reality AI tools in general. So, in your opinion, what does the future of AI innovation at Renesas look like? Are there any upcoming developments, initiatives, advancements in the pipeline that our listeners should be aware of? So, Mo, may I start with you?
Sure. Sure. I think we just think about from data to deployment, right? First of all, we are trying to make the developer's journey easier, right? By integrating the AI and the embedded workspace together. And as Jeff alluded to earlier, that we have a integrated development environment called eSquid Studio, which is designed to develop, and start programming of your microcontrollers. We actually having an add-on to that, where user can optimization and feature extraction that Jeff was explaining earlier, develop a model and seamlessly import that model into his embedded workspace. I think that's going to be a big starting point for our customers too. So that's where a lot of innovation is going. The second part that we're working on is so-called AIoT stack. We're trying to go up the value chain and providing a complete host of software stack, starting from, of course, microcontrollers in terms of peripheral drivers, different libraries, and then going all the way up to application examples where they have a quick start. And I always say quick time to revenue. We're putting together some application examples, in the motor control space, of course, in the HVAC space, certain automotive space, certain target segments customers can take, have a running start and develop their model quickly. And thirdly, the complexity is growing, right, in terms of the embedded processing architecture. We're having now to deal with, different CPU architectures. So the heterogeneous architectures are in play now. You have a CPU, you have a neuromorphic unit, some sort of AI accelerator. How do we make it easier to compile for the different architectures? So we are working with our partners, in this case, a company called Edge Cortex, to develop a heterogeneous compiler as well. And then moving along, doing a lot of work on the transfer learning space to say, okay, as the device is in the play, how we can actually increase that intelligence. And as well as that, then into our embedded processing space, we have our own, what we call is the DRP, dynamically reconfigurable processor, which is basically an engine to accelerate your AI workload. We're looking at other AI acceleration in hardware to support that. And finally, look, it's got to be, we got to have a secure system. We have a functionally safe system. So we are adding a lot more intelligence in terms of security, functional safety, and ultimately, as I said at the beginning, making the solutions more sustainable. So they are low power. So it's a complete, what I call is data deployment. And then finally, we're looking at data ops stage, working with our partners, to actually provide customers once the device is in the field, what happens. And in between, we have a very extensive ecosystem partners, in terms of vision, voice, analytics to provide a complete solution. So yeah, a multifaceted approach to continue to lead in this market.
That's really interesting. Jeff, would you like to add to that?
Yeah, I think I emphasize just a few of the points that Mo made. I mean, he mentioned this heterogeneity, and I think that is a driving factor right now. We do have an initiative to tie all of our AI offerings from the MCU up to the NPU lines sort of into a common framework, so the user doesn't have to think so much about what they're targeting, and we do some of that work for them. And I think we'll probably see some of that coming around the 2025 period. Also, again, I talk about more about solutions rather than AI build tools, right? I think you're going to see more and more solutions that are being introduced where we solve a problem, or at least make a good start at solving a problem that the user can then customize rather than building from scratch. Because building, everything's data driven, and that data is expensive to collect. And once you've got the basic idea for a problem space, you don't necessarily have to go back to the beginning. And this also couples to what Mo mentioned with the transfer learning, right? When you get to deep learning type models, that's the way you do that. You take a model and you use transfer learning to adapt it to your particular application. So yeah, these are the things I think are going to be coming.
That's really exciting to hear. I mean, I'm really looking forward to see how this progresses. But as we speak about AI, and I mean, our listeners already have seen this. Like, it's arguably at the peak of its hype today, right? We all know the Gartner hype cycle showing where AI is today, and given that sort of state that we're in today, do you believe AI will live up to this hype? Are there any clear challenges ahead of its, say, deployment sort of ubiquitously? And maybe bringing Renesas to the question, could you discuss the strategy that Renesas is employing when it comes to integrating AI technology into the solutions and overcoming such challenges? So, do you think AI will live up to the hype? What challenges do you think there are ahead in the next sort of 1 to 2, 3, 5 years? And how's Renesas sort of integrating the technology from their side? So, Jeff?
Sure. We'll start with the hype, I guess, right? I mean, I think no technology fully lives up to its hype before the public, kind of gets bored of waiting, right? We're all get excited and we have expectations and they go up exponentially. But the interesting thing about AI as a field is it seems to find new and unexpected ways of generating new hype these days, rather than spending time living up to yesterday's hype. That's sort of the way I would put it, right? I mean, we can talk about natural language interfaces and voice assistants. We've all been waiting for that since the 1960s science fiction, right? But no one really saw generative AI coming until it basically ran us over. And I think that's fascinating, right? So it's a little bit of a different animal than previous technologies that way. It's in the news all the time, the good and the bad. And maybe that is helpful for us in the field because it's catalyzing a faster transition from Hollywood expectations to maybe reality, right? Here's what went wrong. Here's the limitations. We're not building the Terminator.
Yeah.
And people understand that a little faster than they might have with previous technologies. So that's all opinion. But as I said earlier, ubiquitous is really the wrong word, right? Because we both, Mo and I have touched on this. AI is running on big server farms and AI is running on tiny MCUs in your air conditioner. And they're not really necessarily the same thing, even though they fall under the same umbrella. And we sort of loop them together naturally. So the Renesas COE strategy is to recognize this and nonetheless try and bring all the AI offerings into a common framework that's scalable from MCUs up to MPU product lines and does useful things for customers quicker and easier, no matter their target. Mo, you want to any thoughts on strategy for dealing with this?
I think you covered it quite well. I think to me, look, hype is one thing, but ultimately, I'm on the ground meeting customers, different industries day in day out, and ultimately, it's going to boil down to two things. One, are we improving to what the system is today? Are we solving a real problem, right? And second, are we making the life easier and more smarter for the people who are actually, consumers or even B2B? No one is going to adopt this, just as a feature set. And I think the answer to what we're seeing today is very promising. You look in the healthcare space, the work that's going on there is phenomenal. To be able to predict a certain disease, or to be able to predict, earlier a failure of a system which costs a lot of money, or even scalability in the future. I think where the challenges is going to come is, think about the Gen AI now, right? It's okay in the big content space, and you got lots of cloud resources to run this. Ultimately, to be able to run that Gen AI on the edge, that's the real test. I think, can we really make it sustainable? That means we, as the embedded processing leader, will have to continue to innovate in terms of what hardware features we can provide, together with the software, so we can do that, and ultimately enable that distributed computing that started from the sensor space and going into the Gen AI. I think that's important. And finally, I think security is a big topic there. If you think about it, in Europe, for example, we're talking about a new European Cyber Resilience Act, right? It's all about, is your data secure, right? Is the AI is going to be dependable? Remember, I talked about deterministic behavior of AI into real world applications. So I think we cannot ignore the security aspect of it. So we have to play our role in terms of, we can provide a more secure hardware. Gives customers the ability to be able to determine what the model is doing, and actually be part of that whole journey. And finally, I think, it's all about, innovating in this respective sphere. And we're not going to do it alone. We work with a whole host of ecosystem partner. It's really going to be an industry effort, and together with, of course, legislation was taking in place as well. But nevertheless, it's exciting. It's keeping us on our toes. And of course, customers also finding ways to innovate and add more features and more options to their products.
Absolutely, absolutely. No, this makes a lot of sense. Now, Jeff mentioned how people are getting to understand the technology more and more, and sort of differentiating it from the sort of the Hollywood dystopian way of technology. And this sort of brings me back to what you said, Mo, before about explainable AI, and I want to revisit that point because at the end of the day, for someone to be dealing with AI, it's about, as a company, it's about remaining competitive and profitable in the marketplace. So for a company that has made an investment in AI with Renesas, let's say, how would they present the value proposition to what might be, let's say, a relatively non-expert or maybe unsophisticated customer base? How would you consider that?
So I'll make a start and I'll hand over to Jeff to a little bit to elaborate on the explainable part from a technology point of view. I think, look, depends on the application. We talked, for example, a lot of the, I gave you an example of that power tool earlier, right? I'm a customer, I have a lawnmower or some battery power tool. What I'm looking for is that my investment and my user experience is optimum with what I've done. So the impact of AI for me is that my battery is going to last longer, right? I'm going to have a long, so, and the AI is behind the scene is helping to do, we talked about how to, have less sensors to look at those conditions when it's, being overheated. Similarly, if it's let's say we talk about green energy applications like solar inverters and stuff, right?
Right.
What can we do in terms of optimum performance? So look, so it's different for what I get as a consumer and end customer to what the customer is doing, right? So I think ultimately everybody has to benefit and improve their quality of their experience, and of course the product features, ultimately to be able to sell more in the market. But yeah, I mean, I think I touched a little bit from an explainability point of view earlier, that you want to make sure that what you're putting out in the market is what as its intended use is what it's doing. But I'm sure
Right.
Jeff has more to add to this.
Sure. I think there's several levels of the word customer in that question, right? It seems to be you've got our customer, which is probably going to be an equipment manufacturer using the Renesas MCUs or MPUs in a product, and then there's their customer, right? And some degree we're addressing that final customer in terms of the value, and they're getting a smarter product, something that does something it couldn't have done last year, and still remains in the same small package. But from the point of view of our direct customer, that is the people developing things with Renesas MCUs and MPUs, really what we're offering in AI is it's an engineering labor saving device, right? That's what we're doing. It's a faster way that to get to a solution. Engineers aren't being replaced. In fact, they're being a help. It's a tool that can leverage this to solve problems faster. Get to the part where they can really apply their expertise faster. So that's really, from what I see, for our customer, the value proposition.
Mhm. All right. Well, this sort of concludes. I mean, of course, I would love to continue this conversation much, much longer, but for the sake of time, it concludes what the conversation we had for now. But I can see we have some questions for Q&A. So if I may jump quickly into the questions, so we don't waste time. One of the audience, one of the viewers asked. Do the Reality AI tools support neural decision processor-based TinyML? So how would you answer that? Do the Reality AI tools support neural decision processor based TinyML?
So the short answer is yes. We are now supporting neural networks, and we're being increasing increasing features that are released over the course of this year. If they mean specifically NPUs, then that is at least at the level of MCU processing, right? That's really a matter of the compilers, right? So if we're working at ARM, SimSys, interfacing with some of their neural processing technology, for example, that will be naturally supported as part of the compiler chain. If they're talking about more specific NPUs, I mean, there are many players out there, including our DRP AI, right, which is another neural processor that we use here.
Actually, speaking of NPUs, another question that sort of speaks about those is what technology nodes do you see the most suitable beyond the 40 nanometer level to have AI models running on NPUs within the power constraint of the edge? That is a really interesting
I'll
detail.
kickstart this one. So, again, you talked about a lot about a very diverse set of application when we talk about AI, right? We want to make sure we talked about the independence of the edge, right? Meaning we want to be able to run more on that processor. So with all of that backdrop, that means there's so much, evolutions happening in terms of the processing side. So, we have in the mainstream MCU space, we have products which is running on the 40 nanometer process technology to be able to do multi-model. So you have, for example, our RA6 products, RA8 products, which can run multi-model in terms of some of the vision models, some of the voice, perhaps. So it really depends on the application. But there's a more complex one when you're looking at more application. We have our products in the 22 nanometer space, or even 28 nanometer, going down to 7 actually in the MPU space, right? Which is so. I think it's a complete. So what I can say to answer to this is that we have the devices, very very wide range of devices to really address specific application, and we choose the process technology quite carefully for two reasons. As I think within the question, power consumption is a big thing, right? So, for example, we have a new RA8 microcontrollers devices running in 22 nanometer, right? Really optimizing the power saving, and then down to a very small microcontroller, which is maybe a low end micro running on our in-house low leakage processing on 110 nanometer. So I think we're selecting the right process for the process node for the product, and then targeting to specific applications. So and it's a journey, right? Look, I talked about earlier about Gen AI, right? If you're talking about Gen AI running independently at the edge down the years, then I think a lot more innovation has to happen to make that really power efficient. Hope that helps.
Mm-hmm.
I think whenever we talk about putting AI on an MCU, we always have to remember it's part of a package deal, right? So just as proof of concepts, people in the TinyML community have put amazing models in very small places. But one of the things about that is they've used every single possible resource on the chip. And that's actually not realistic, because we need to leave space on those chips to do something else, right? Solve the actual problem or act in some control fashion that the customer has chosen it in the first place. And so it's not whether you can make it fit, it's whether you can make it fit and run all your control software at the same time, right? So smaller is still better. Even as we add these capabilities, smaller is still going to be better. And you don't want to waste space. You want to leave room for the developer to build their own application.
That definitely makes a lot of sense. I totally agree with you. The next question is a bit more general, actually, and it's about sort of partnering with Renesas. And someone is asking, what's the process for partnering with Renesas? How does the process look like? So maybe give a brief overview description.
You
Someone
know,
wants to.
look, AI or any core technology, it's only going to be successful in partnership. And this is what we strongly believe in at Renesas. We have a platform called Renesas Ready Partner Network, where we have defined a set of about 8 core technologies, AI being one of them, but of course there's HMI in there, there's security, there's safety, sensing. And, we have a process where if there's a good match of that technology and it can run seamlessly on our hardware, we work with partners to develop some proof of concept, some demo that we can actually, support the customer with. So it's called Renesas Ready Partner Network. You can go to our website and actually get in touch with us, and we can have that conversation. But we welcome new partners where it makes sense for our customers. But we're really focusing on quality rather than quantity to make as well. But really open to that in all of those core technologies.
All right. Jeff, do you have anything to add to this?
No, good coverage.
All right. Then I guess, well, thank you all for your questions. If there are any extra questions that you have, make sure to reach out to us and ask them that we can get them to our panelists to answer to you. But I just want to say thank you to both of you, Mo and Jeff, for this insightful conversation. It's been really enjoyable, really helpful, and it's a pleasure for me to have this chat with you. So I really appreciate having you here. So thank you.
Oh, our pleasure.
Thank you.
Great. And to all of you watching, thank you as well. It's been great having you all here. And as just mentioned in the beginning, don't forget to check out the report if you haven't already. I think you're gonna like it. It's free to download on the Wevolver website. Thank you all for being here, and I'll see you all in the next webinar. Wish you all a very nice rest of the day. Cheers.